To be able to achieve an industrial relevant quantum advantage, one needs to efficiently create, store, and exchange quantum objects of more than 50 spins. We have created the Struqture Python library to achieve this goal. Previously, we have shown how Struqture can be used to create a large spin Hamiltonian in few lines of code. Today we will show you how to work with spin Hamiltonians after they have been created. One often encountered quantum model is the Ising model. This model has single spin terms for each spin and a ZZ coupling between spins. Now assume you have a program that calculates a ground state property of an arbitrary one-dimensional Ising model, and you want to test it. We can create a random Ising Hamiltonian with a few lines of code in Struqture. However, what happens if someone hands you some new Ising Hamiltonians to test your algorithm? You will probably first want to know if your classical or quantum computer will be able to handle the Ising model in question. With Struqture, it is easy to check the maximum spin number in the Hamiltonian and therefore how many spins need to fit on the computer. Sometimes one also wants to check the value of specific terms in the Hamiltonian. Let us assume that a quantum algorithm working with the spin Hamiltonian never couples qubits 2 and 3. Unless coupling between spin 2 and 3 is also 0, this could mean there is an error in the code. We use the same indexing we use to create spin Hamiltonians and the get function to query a specific interaction. When such a coupling is 0, the Ising Hamiltonian would separate into two smaller Ising Hamiltonians. If we don't want this, we can again use the indexing and the set function to override the coupling. Another widely used model is the Heisenberg model, distinguishing itself from the Ising model by having all three spin interactions. Assume you have been handed a Heisenberg model with randomized couplings but no magnetic field by a collaborator, and you want to test the behavior of this model with different magnetic field strengths. With Struqture, we can create another magnetic field Hamiltonian with a given magnetic field strength B. The two Hamiltonians can simply be added to obtain a Heisenberg model with a desired magnetic field strength, and use this as an input to an algorithm. If you got interested in Struqture, it is open source and you can have a look at the Struqture library on GitHub.